So welcome again today to Why Lean, which seems like as I told a friend of mine today, why lean sounds like something you'd put on mushu pork to make it tastier. Um, but it really is the heart and soul of the reason that we're trying to change the way that we build things in the built environment. And as odd as the name is, and as hard as it is to define, it does carry a certain set of principles and standards that are different than the principles and standards that we use in the way that we build buildings in the world today. So if the problem is we should focus on how we build buildings in the world, then there's really five things I think that we have to think about. We want to create buildings that work, because buildings that don't work don't make much sense. We want to create buildings that can be built in a reasonable time. We want to be able to build them for a reasonable cost. We want to do it with the desired quality. And we don't want to sacrifice some or other more aspects of the solution for another. So we don't want to prefer time over quality or quality over value. We want to spend our time delivering the very best that we can for every building that we're building in the world. We're
Hey Dick,
concentrating on.
before
Go
you
ahead.
continue, do you guys see Dick's screen? Do you guys see Dick's presentation? I want to make sure this is. Are you sharing your presentation? So we don't see a presentation being shared, Dick.
Oh, you don't? Seriously?
Let me see.
Okay.
No, I don't. So let me try to.
Well, here's what we can do. We can do this.
Or share.
Sure. So let's share this screen. Can people see that?
Yeah, I'm seeing it right now. Yes, we're seeing it now.
Okay. So we're not going to get the fancy. We're not going to get the fancy animation from this, but that's okay. We can just send it out without the fancy animation because I've got like 9 screens to share here, and apparently that one that I was trying to share wasn't working very well. Let me try though, one more time. See if that works. How's that? Can you see the presentation now? Just nod. I can see some of you guys.
Yes, I see it.
Okay. All right. So getting back to these buildings, the reason that we build buildings in the way that we do is to try to get to a certain level of performance that's going to enhance the built environment. We have a certain paradigm under which we operate, and that paradigm means that it is a way of understanding how we are going to go about building these buildings, right? That's what a paradigm is, a comprehensive model of understanding that gives us rules on how we look at the field problems and how we solve them. And our current paradigm is a paradigm that's built around a number of assumptions that don't make as much sense today as they used to. But they used to actually, as Greg Howell said, oftentimes, there is a coherent current practice. It may not be the current practice that we want, but it is coherent. So when we think about changing that paradigm, we have to think about what is that paradigm built on? And that paradigm is built on a number of different things. So does everybody see Moses with the tablet? Okay, good. As long as we see Moses with the tablet, we're good. So these are the base beliefs. This is kind of what went into our original paradigm. The buildings are complicated. Building them is risky. Because they're complicated, we need to split them up into little tiny parts and work on those little tiny parts. We should always start with just a base design so we know what the building is going to look like. Then we take that design out to the market and we have a bunch of people try to price it. And then our goal is to hire people to build it based on what they think the price should be. And then we often find that the price is too high. So we go back to redirect it, redesigning the building that often eliminates program from the building, which is called value engineering, like Monty Python's famous Knight over there, merely a flesh wound. And then we start to redirect repricing and redesign into a cycle that we get to something that we can build for the money we have. So this value engineering process usually always means a reduction in the overall value to the customer. And then we hire somebody who's going to build it for that new design. And we hire them based solely on the price that they commit to it, without regard for the risk of hiring them to do the things that they may not be able to do very well. Because buildings are risky, we tried to figure out a risk sharing or risk mitigation approach that has allowed us to sell pieces of the risk to individuals that we hire. So if we have a $10 million drywall scope, we sell the risk of that to the drywall contractor. So the drywall contractor's company is at risk to deliver that scope, and they're routinely crazed about trying to protect themselves from the risk rather than trying to deliver the best value that they possibly can. We leave the hiring of all the trades to a manager, a construction manager or a contractor that we've hired, where we've sold the entire risk of cost and schedule and quality, and we let them try to sell components to the trades. And yet part of their strong belief is that the trades can't be trusted to build without their leadership. Without them, everybody on the project would fail. We can know what buildings will cost is one of our assumptions, and we can know how long they take if we just make enough assumptions. So there's a reason that we call estimates estimates, because we're making assumptions about things. But because the business of each of the pieces is opaque to the other part of the business, we don't ever ask anybody to share any information. As a matter of fact, our business practices make that information confidential and not open to discussion with anybody. So the risk of failure is hidden inside the financials that are behind that opaque screen. And we don't try to do anything with them except create a contract that passes that risk on to them. And our assumptions are really an accumulation of our prejudices and our biases. So I've taken a picture of my bookshelf that's right next to my desk here. That's got some of Daniel Kahneman's works about judgment and under uncertainty, heuristics and biases, the way that we accumulate our thinking about projects is based on the way that we were raised to think about them, and we don't even challenge them on a very regular basis. And although we create an enormous amount of data, we hardly actually use the data for anything approaching getting real jobs done. So our leadership is based on driving the trades to complete their work. So here we've got the longhorn cattle. Everybody see the longhorn cattle? I want to make sure you're following along with my screen here. The bouncing ball. So we have a driver, right, that drives the longhorn cattle, and we assume that the longhorn cattle don't know where they're going unless we're driving them. And then we report back to the owner on a regular basis. Every 30 days, we let them know how far down the Santa Fe Trail we've actually gotten. We don't actually report real costs because costs are owned, the cost piece of it is owned by somebody who doesn't report it out. So we never really know where we are on costs. So if somebody's going to come after us for a claim of some kind, we don't know then that until it's way too late for us to do something about it. And the risk of contractor failure is covered by a bond. More on that later for those of you in Ontario and in Canada. There's recent things that have come forward about IPD bonding, which is kind of crazy in its way as well. But the risk of failure of the building itself is covered by insurance, and then everybody else has to bear the risk of not complying with the things they're supposed to be doing. So this is me lying around being confused about all kinds of things. And the one thing that I'm confused about, because I wasn't, I came into the industry as a lawyer whose job was to find the guilty party and punish the innocent on a regular basis. And what happened was that I got confused that why do we have all these estimates and all of these guesses when we actually could know a lot more than we go out to find out. So rather than trying to be a general contractor and pricing as much as based on your own kind of estimation software, why wouldn't we go ask the trades how much that stuff would cost? Why wouldn't we ask them how long it would take? And that's why I was drawn to the whole idea of lean design and construction, because we have the ability now to go out and ask people what they think. So there's a very famous guy who I've been following for many years, and I like this fellow a lot. His name is Bent Flyberg, or Friesberg. I don't know exactly how to pronounce it, but one of these days I hope to meet him. But he's an interesting fellow. He's probably the leading expert in the world on cost overruns and projects that have mega projects that have overrun. And he has an iron law of project management, which is basically over budget, over time, under benefit, over and over again. And if we keep that in mind as the goal of what we're trying to accomplish, then the data doesn't really matter that much to us. Because in fact, the data supports the fact that projects are routinely behind schedule and routinely over budget. But all of those who've actually worked on projects, we know how frustrating it is to even try to bring in a project on time and on budget because of the way that we have to manage the people. We know that productivity and projects continue to underperform. We know that productivity in every other industry outstrips the productivity in construction. And we know that we've got world-class champions in projects that are over budget on a regular basis. But for today, I don't want to concentrate on the data. I want to concentrate on the people side of this. I want to concentrate on the reason that we try to bring new thinking and a new paradigm to the whole construct of how we think about the built environment. And I've really begun to think of the built environment as a rainbow that starts with the programming piece when we first start that we need a building, and ends when we tear the building down to replace it with something else. So it's an entire rainbow, it's an entire arc of the life of a building, and why we separate that into so many different parts is one of the discussions we'll have today. So if you take a pretty simple building and you figure out what it is that we want. So I've always liked this building. I don't think it's necessarily that simple, but it certainly shows what it's supposed to be doing. It has a representation of what's going on, and it apparently works really well inside. So if our goal is to go back to the 5 things we said we wanted to do, we want to create buildings that work, that can be built in a reasonable time at a reasonable cost with the level of quality that our customers desire without sacrificing one value for another value. We have to think about this in systemic terms. So going back to the paradigm. So the book that I showed up here, I don't know if any of you have read this. This is a really great book. It's called The Structure of Scientific Revolutions by Thomas Kuhn. And he was an MIT professor of philosophy and the history of science. And he wrote this book in the 60s, and it's stood the test of time. But he came up with this thing called the Kuhn cycle, because everybody has to come up with something that they can be named after. So I have the biocorollary. I just have to figure out what the original proposition is that it's a corollary to before it'll get famous. But one of these days it'll get really famous. So the paradigm in the Kuhn cycle is basically that before we develop a model about how to approach things, we live in pre-science. And then we move into something called normal science, because he's writing about the history of scientific revolutions, but it goes for every system and every model. So there's a model that's created to how you process normal science. And then that model starts to drift, which means that the model starts to be challenged because some things just don't fit into the model very well. And then there's a model crisis where the drift becomes so extensive and so pronounced that the model appears to be broken. And any attempt to fix the model by design build or by tougher contracts or by something else doesn't work because the model is fundamentally flawed. And then there's a model revolution. So the cool animation that I had here, this is a little apple that I actually drew, so that's going to be part of my corollary. The cool animation I had here is this apple falls on Newton's head. And I use this all the time because I think it's so demonstrative of why we really need something like lean as a changed paradigm. We need to think about things differently. So the apple dropped on Newton's head and he comes up with this idea of gravity, right? But at the time that he comes up with the idea of gravity, the book of knowledge has the sun revolving around the earth and the earth is flat. So it's not like he can just write a chapter on gravity and put it in that big book of knowledge, because it just doesn't fit there, because it challenges every assumption that's in the big book of knowledge. So we have to rewrite the book of knowledge. We have to create a new paradigm, because the system can no longer generate the desired results based on the theory and the way that we're proceeding. But it doesn't go away until there's something to replace it. That's fundamental to what Kuhn's thinking was, is that the decision to reject one paradigm is always simultaneously the decision to accept another. So these things just don't happen overnight, though. I mean, if you remember the story with the things that happened to Galileo, he comes up with all kinds of great ideas, and then he's persecuted. Things don't happen overnight because people have invested in these systems. Just think how much construction companies have invested in PSEC scheduling, for instance, the whole concept of scheduling, or how much money they've invested in their estimation software. And yet how many construction companies at the end of a project actually go back and adjust their estimation software based on the results that they had in the last building? In my canvassing of construction companies, very few. Even though that data is available, they don't feel like they have the time to go back and change their entire system to make that happen. And yet that's exactly what needs to happen. So why would we do lean? Why would we even suggest that there's a paradigm shift that could be called or structured as something called lean? Well, because if we look at the system and we focus on the value we're trying to get out of the system, we have to see if the system is generating value. So Lori Koskela, who is one of the founders of the whole lean movement, a Finnish fellow who now teaches at the University of, one of those universities in England. He was at Salford for a while and now he's someplace else. But he's a smart guy in the community, and a number of his contributions have been about academic descriptions of how work gets done, by the unit or by the flow or by the transformation process. But he also came up with this idea of the principles of value generation. And when Dan Fauché and I first met Bill Proctor back in Sacramento in 2008, we were sitting around thinking about 400 people coming to Sacramento and getting together in a big room to go do some lean project that nobody had ever done before. Nobody ever thought about it. And I remember Proctor looking at me, and he had this look in his eye like, you know, Byron, you might be one of those guys that could figure out how to do something nobody knows how to do. You look like that would interest you. And in fact, that's what really interests me now. I have these conversations with my architect friend, and we've decided that the things we do really well are the things that nobody knows anything about, because they're more fun to go out and try to solve. So the first thing I thought about with Dan was, if this is all centered around value, we have to have a discussion about what value is. How do we know what value is? How do we focus on understanding what the value proposition is? So Lori Koskela, as a academic, has given us some ideas about how to focus on the value proposition. And he's created 5 different ways of kind of looking at it. And we add those to the 5 different things that were very early on in 2004, part of the lean community, lean design and construction community. So we should never cut out the architects here. We have to remember that when Greg Howell and Glenn Ballard came up with, along with Todd Zabel, which is a name you'll hear a little bit about later, and Iris Tomaline came up with the idea of the Lean Construction Institute. They thought of it as the Lean Design and Construction Institute. They just didn't want to make the name that long. So design is every bit as important here as construction. But there are 5 big ideas around what things were these 5 ideas that we're going to revisit as we go through this. But they're really about how we integrate the process of design and construction by getting to know each other better, increasing relatedness, collaborating, really collaborating. I remember giving a speech up in Malbay to the Canadian Construction Association. And you should look up Malbay on your map if you're not familiar with it. It's about 200 miles and about 5 decades north of Quebec City. And it's a very interesting and beautiful place, but they don't speak English up there. But somebody in the audience said, well, what do you mean really collaborate? And I said, well, you know, coming from America, you say to people, oh, we have to collaborate. And they say, oh, yeah, we collaborate already. And I said, no, 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 you have to really collaborate. And they go, oh, so we have to really collaborate. Right. Oh, now we get that. Okay. We talk about projects as a network of commitments because there are so many different interdependencies. You'll see in here from Peter Senge, who writes about systems, about the network of interdependencies in every kind of system. So one of the reasons that systems don't work very well is because they have unforeseen consequences based on the reaction of those interdependencies. And then the other thing is if we're learning something, why wouldn't we just put that into action right away? So this is one of the reasons why construction companies and design firms shouldn't do lessons learned at the end of a project. They should do it every 2 or 3 months because you're learning things that you can apply to your projects right off the bat. And finally, you have to look at the whole project. We can't cut it into pieces anymore because we've proven that just doesn't work. So if we look at the 5 values that we're creating this workshop around, first is to create buildings that actually work. So wouldn't it be cool, and my friend John Cook knows this better than anybody, at Brown University, at University of Chicago, at Yale, at Harvard, buildings are signatures for those campuses. And before the trustees are going to approve a building, they want to see some cool rendering of how cool it's going to be. And so when you hire expensive firms like Diller, Scafario, and Renfro, or you hire Kieran Timberlake or some of our well-known architects, they come up with something that has to go to the Board of Trustees, and the Board of Trustees goes, oh, that's so cool. Yeah, let's go build that. So at the University of Chicago, they built a $1,200 per square foot building, the DSR designed. It's a bunch of glass boxes on top of each other as a welcoming center. So that's what you need, are glass boxes on top of each other. So how about if we change the paradigm and we design buildings from the inside out? How about if we design the systems first? So we didn't have problems with floor to floor height. We didn't have problems for fitting in the mechanical rooms and the electrical rooms. What if we actually thought in terms of buildings that actually worked? So what does that look like? So I said we're going to hear from Todd Zabel. Todd Zabel is a guy who runs a company called Strategic Project Solutions. And he's one of the smart guys out there in the lean community, although he's kind of a nut job. So I don't know if you can get sued for slander for a nut job, but I think he'd recognize that as a compliment. But he came up with this concept that buildings leak at the intersection of contracts. So if one of the fundamental ideas of a building is that it's waterproof, just think about how many people we have tried to piece and parcel out making that building waterproof too. And we have said that they should all fight for space in the building and they should all fight each other because only one of them is going to win going forward on this thing. Buildings are not only complicated, but they're complex. And complexity is something that is little understood by people in the business. So there's a great book called Team of Teams by Stanley McChrystal, who was the head of the Iraqi Joint Chiefs of Staff or Iraqi Joint Task Force or whatever they called it. And when he went to Iraq and took over this thing, he showed up and the allies in that Joint Task Force had gathered all kinds of information from raids on Al-Qaeda houses and all kinds of other things. And they put it in satchels and they put it in a closet and the information never went anywhere. And well, why didn't the information go anywhere? Well, nobody knew who to give the information to. So they just sat there. So what McChrystal decided was that we never know what this information, how valuable this information is going to be to anybody. So he created a virtual big room. And every day, 2,000 people saw all the information that everybody in that 2,000 that group of 2,000 people actually saw. They all saw it together because he never knew who was going to make a connection from one thing to another. And if you think about one of Greg Howell's old really favorite expressions about low associative barriers drive innovation, what he's really talking about is somebody sees a shoelace and all of a sudden they see a new way of designing a hook crane on the side of a building. People make connections between things that are unusual, and that's what gets us to inventions and to innovations. And especially in complexity, where something isn't complicated, like building a jet engine is really complicated, but it was one step after another. The complexity is hiring 3,400 people to build a building, like the Empire State Building, and trying to get them all to work together as a team to make something happen. So those webs of interdependence, as Peter Senge talks about, are crucially important to our understanding of how things work. So when we're addressing anomalies and we're looking at a building that works, we need to look at what's really important to identify what works. So we have to identify a value proposition from the owner's perspective. So how do we go about doing that? Because the one thing that lean construction has done, or was meant to do, was really to increase the reliability of our processes as a precursor to increasing productivity. So lean by itself doesn't necessarily, lean in construction and design doesn't necessarily by itself focus on productivity. There are lean teams that focus on productivity. You look at tack time, they look at ways of improving the time it takes to hang a piece of drywall. But most of our projects, we just want the drywaller to show up when the drywaller says he's going to show up. And we want to give that drywaller a path of work that can be done uninterrupted to increase the flow of their work throughout the project. So we're really looking for a reliable design process that is ensuring that we're designing a building process along with the building itself. And that allows us to mitigate the known and the unknown risks of complexity, because we have to know how we're going about assembling these things. So some of you will recognize some of these pictures about how we align people, processes, policies, and products. We can't do this in a vacuum. These teams can't build buildings behind a tent or behind a curtain. You know, pay no attention to the man behind the curtain because he'll fix everything. Well, man behind the curtain actually doesn't do anything. He just got on a hot air balloon from Kansas. We have to anticipate and mitigate the risks of misalignment. We have to understand how it is that we're going to go about doing things. So we have to be completely transparent about how we're actually going to build these things and how they align in the right way. And Peter Senge shares this observation as well, that you need to get different people from different points of view who are seeing different parts of the system to come together and collectively start to see something that individually none of them can see. So we don't care how smart you are. I used to think that I was a really smart guy, mostly because my brother and sister were not quite as smart. So, you know, when you're in a crew of 3 and one guy stands out, it's pretty easy to be like the smart guy. But when you're in a crew of like 400 people in a big room, you can't be the smartest guy in the room. Everybody has a piece of history or experience that they bring to the table. If you use core clarity as a way of understanding what your strengths are, there's at least 34 different strengths out there that everybody brings to the table. And creating a purpose-built team is something that we're all striving for. So there's a project that I'm chasing right now down in Hamilton, which is southeast somewhere. I don't know exactly where my Canadian friends can connect me, but it's outside of Toronto. It's west of Toronto and along the lake somewhere. But I just had this crazy idea that as the IPD guy, instead of being asked by a contractor and a designer to put me on their team, what if I just formed a team and said, this is the team that we need to do, because I'm going to be the guy that's going to help actually manage at risk all of the things that are going on in the project, because I'm the only one that actually focuses on the project. Because the CM they have mouths to feed and they have people to hire and they have people to bring to the project, and so does the designer. But somebody to get the real value of an IPD contract or a lean way of proceeding, you really need to manage the way that people spend their time. We have to focus in on and work hard at actually how people manage time, because time is what we can influence in how we build these projects. So if we want to create buildings that work, we have to create teams that work to create that building. How about a reasonable cost? I mean, in a reasonable time. So we talk about reasonable time and we're wondering about how fast can we build it. So I want you to think for a second that there are two things that are important out there in the world. There is a time that it should take to build a building. And that time is the sum of all the work that actually has to be done on that building that moves it forward. So there is a time that we just can't snap our fingers and instantly take time out of things. And then there is a cost to pay for that work and to give people a reasonable profit for doing their work. So our goal is to try to figure those things out as quickly as we can. But the tools that we use right now are not much help in getting us there. So I quote myself here on one of my great observations. I like to think that I'm a great observer. It takes time to build a building. Okay, so we have to recognize that. But how we get there, it's too bad that my thing isn't working, or that I can't animate this, but this is a great animation that I put together and use on PowerPoints all the time. This is on the left, there is a film of the Empire State Building actually being built. And on the right is the story of how that building got built. So excavation on the site started in June of 1930. And by May 1st of 1931, the building was up. And the question is, wow, how did they do that? They must have killed a lot of people. They must have used a lot of people. So they used 3,400 workers, which on a building of that size is more, it's probably more people than you would think, but it's not that many people. But the other thing that they did is that there's this great book, if you're interested, called Building the Empire State. You can get this from the Empire State Building Museum. But they talk about how they actually went about doing this. So this is 1930, right? And this was a time when people realized their limitations. So as related in this book, it says, because the architects, builders, and subcontractors didn't feel competent to develop the specifications on their own, they called in the subcontractors who rolled the material, representatives of the metalwork fabricating it, those who were to erect it, and the inspectors who were going to test the sheets at the several stages. That conference made possible decisions based on instant comparison of recommendations and establishment of the responsibilities of all those involved. So this is 1931. That sounds a lot like target value design, bringing in all the people who are actually going to build the project and getting them thoughtful around it. And Paul Starrett, who was one of the builders, said, back looking on his career, he said, never before in the history of building had there been, and probably never will be, an architectural design so magnificently adapted to speed in construction. So the secret of the Empire State Building was they thought about how they were going to build it as they were designing it. They designed it from the top down. They said the hardest part is going to be the top, so let's design that from the top down. So that sounds like a pull plan to me, where you start at the end and you move backwards to figure out what are all the things that you need to do. So these guys had this figured out in 1931, but nobody was actually listening to them very much. So when we address the anomalies of the right time, do our schedules that we crank up, how much do those schedules actually help us understand the plan of attack? When you look at the schedule on this picture, does it make you go, oh, wow, that's a great plan? Or does it just make you go, wow, that's very confusing? I don't know of the 117 people that are listening to this, how many are architects, but I've never found an architect who relished or who enjoyed or even could necessarily read a 42-page P6 schedule. So you get into a design build arrangement with somebody and the CM has given a schedule out to the architect for 122, that's fantastic. For how their tasks need to be done. And the truth is that architects don't do tasks. I'm sorry. Architects do deliverables, but they don't do tasks. They gather information and they iterate various options that can be built based on that and they make things happen. Apparently, I'm drawing all over my screen here. So our scheduling processes don't address how we get to the right time, because we have some person on a computer trying to put together all these different pieces, and we don't actually share that with people. And the way that we monitor those things are, every 30 months or every 30 days. So back to Todd's Bell. The cool thing about his company is that he's got this very elaborate algorithm about how you do a process piping plan. And he'll go out with his project managers, and at the end of the day, the manager or the PM or the assistant PM or whoever who is assigned to a certain part of the piping plant records how much work actually got done that day. And then that team stays up all night and runs this program that spits out what the schedule should look like tomorrow. So if you use your P6 schedule that way, so that every night, everybody from every part of the work gets together on that P6 schedule and reforms it based on the work that's actually been done and where that work is going, then it might be a valuable tool. But how much more expensive is that than just guys pushing stickies around a wall going, oh yeah, well, this is kind of cool. So what we try to do is we try to devise all kinds of systems like Rube Goldberg did to make things easier. And we use technology that's not suited for the task. There's some great technology that's suited for the task out there. We were in a meeting the other day, we were talking about a number of options for a residence hall that's being built on top of another building. And the original design called for a transfer slab, which a transfer slab is about a 15-foot thick, as we say up here, 4 meters, I guess, 15 or 16 feet thick, $1.5 million to create a foundation on the 4th floor to carry this stuff from the 4th floor to the 8th floor, because the original foundation doesn't do it because the grid changes. So all of this is really interesting engineering to me. But we're always trying to figure out technology that can kind of get us to the point where we can just push a button and things work. And the truth is that works in factories. And this is one of the differences between lean in the factory and lean in design and construction, is we just can't push a button every time with the same process. So we have to spend some time deeply thinking about coordination and integration and collaboration. And that's what actually gets us to figuring out what is the right time. So here's a little film. I'm going to try to make this, I'm just going to just make this bigger so you guys can see this. This was a team at a hospital outside of Dulles. And we were doing a phase plan. And the phase plan was trying to figure out how to get to closing the ceiling on the 1st floor. And the superintendent had talked to all the trades and said, it's going to take us 23 weeks. He couldn't get anybody to back off their duration. So if any of you have ever played the Make a Card game, the Make a Card game is a really cool little game where there's a team of 6 or 7 that have to put round stickies on cards and see how many cards they can produce. And so we have these rules at the beginning of the card game that people end up doing maybe 6 cards in 6 minutes. But by the 3rd round, where the rules have been completely relaxed, people are doing 85 cards or whatever. And the thing that has changed is not that the work has increased. So the work is taking the dot off of the plastic thing that it comes on and putting it onto the card. So it's not like the speed of it just takes about as much time as it takes to take that dot off. There's a couple ways to make it a little bit faster, but it's not that the work increased. It was the space between the work decreased. So what we do to try to get to the right time is we take out all the fluff between that. So this superintendent had decided that I don't know what's happening with these things. It's very weird. Somebody's drawing on my screen. The superintendent had decided it was going to take 23 weeks to do this. And so I got everybody together in a room, all the trades, and they wrote down all the work that they were going to do. And then they went up to this big board and they started writing down the work that they were going to do. And whenever you do this, you need a Rolling Stones song. So this is what we mean by collaborate, really collaborate. All the people who are doing the work outside of the superintendent are up at the wall figuring out what the work is that's going to be done. And over here in the corner is the superintendent. He's not up there telling people what to do or what he thought about or how he was going to do it. They're up there actually doing the work themselves and creating this phase plan for this piece of the work. So what's the upshot of that? Well, the upshot of that was that at the end of the day, they had, because they decreased the space between the work, not a single duration, I think this is amazing, not a single duration of the trades actually went down. All of their trade durations stayed the same, but the work could be done now in 17 weeks because of the way they took out the space between the work. They figured out how to flow the work, which was phenomenal. And the system, I don't know what happened. Somebody wrote all over the screen that I'm sharing here. Sorry. Can you guys see a blue streak across the screen? I don't know what happened. Maybe I just swept out my arm in some crazy fashion. But anyway, the way to address the anomalies about the right time is to look at not only what work has to be done and what can be done, but focusing on the kind of work that actually can be done by going back to your trades and finding out how you're going to create a flow of work and then how are you going to make that work ready. So there's two things that have to happen, right? There is a flow of work that has to be done. And then all of the work that has to allow that work to flow has to be done as well. So we have to procure stuff. We have to get stuff to the site. We have to get designs to the site. We have to get answers to the site. And then we have to get the workers into a flow. And that's how we can create what is the right time. So how soon can we know that time? If we're trying to figure out how long this building should take us, how quickly can we know what that time is? Well, we can't do it any quicker than the time when we get the trades involved to help us figure that out. So what's the only contracting process that we have right now that allows us to bring those trades in free? I mean, in earlier than our traditional way. Well, one is clearly IPD. But if you think about how you could build a design build team, you could build a design build team where you're bringing on your trades and you're putting together your entire team at the beginning of your pursuit. So how do we get to a reasonable cost? And this is another buyerism. We can't tell how much anything is going to cost until we build it, right? So the truth is, the final number that this building is going to cost will be known on the day that John Cook writes that last check. Then we know exactly what it cost. And then when the building falls apart, maybe we didn't know exactly what it was going to cost. But how do we get better at trying to figure out what that cost looks like? So there's a couple of things we can do. We can focus on value. We can click to add a title. And if we focus on value, we have to look at a couple of things. So this is something that I've been working on with my friend Ben, where we've been thinking about cost in relation to price. And the cost of things is always less than the price that we pay for it. And so the question that we ask for is why is the price always so much higher than the cost? Well, if you look at all of the things that we throw in, oh, look, the blue thing disappeared. Awesome. If you look at all the things that we throw into our price, there's lots of stuff in this whole system that these are things that maybe we don't need, or maybe we change the way that we do that. Because if you think about it, the number one thing that we can influence on projects is how much labor we throw at the project. So how much it costs us to assemble things and how much it costs us to join things, because the art of construction is assembly and joinder, and the art of design is the creation of what those joints look like. So where in this whole march of costs can we actually reduce the price? We're on a project in Winnipeg, and if you're in Canada, you may have seen this project. It was a 300-bed student residence outside of the University of Manitoba in Winnipeg, and had a tremendous fire just before Christmas. The thing burned down. But the one thing that I take from that project is we were working with the fan coil manufacturer. And so we had this idea about how to do something better with the fan coil. So that idea had to go to the mechanical guy, and then it had to go to his broker who was buying the fan coils. And then the broker had to communicate with the fan coil uh, manufacturer, and then that had to come back up the chain. So everybody got paid in that chain for doing those things, when in fact the guy that I work with, his office was about 2.5 blocks from the fan coil manufacturer, and we could have just eliminated that cost if we hadn't been so respectful of our quote contracts and authority, by just him going over there and talking to the fan coil guy and saying, well, could you prefab this assembly, or here's what we need to have on this thing, or could you do this? Just think about what are the things that are non-value add items that influence the price, and where on this non-value add thing is a customer willing to pay for it. So when you get into the IPD world, one of the benefits of the IPD world, remember that a contract is supposed to just plow the field for us. That's the goal of the IPD contract, is to make it easier for us to collaborate and integrate on the job to deliver the project at the end of the day. It's not supposed to dictate behaviors. It's not supposed to do all these wonderful things that we would like a contract to do. That's not what contracts do. They either tell you what to do or they allow you to do things. And the IPD contract is supposed to allow you to do things. But we lose value on it because we hardly ever think about what are the non-value add items that we do on projects. So if we're buying the air handlers in design, then we don't have submittals. How cool is that? If we are all spending the money in the middle of the table and we're all responsible, we all have the same risk, we're not, as a CM, tasking somebody to walk around and keep track of the trade so we can make claims against them. We're not doing RFIs because our architect is right there as part of the team. We're not doing SIs. We're not doing contractual things that people have to pay for outside of their scope. So we've eliminated lots of the non-value adds to the contracting process based on customer value, because the customer is willing to pay for some additional stuff, but are they really willing to pay for all of that? So why would a customer ever want to pay for punch list work or defective work or trade damage or RFIs or submittals? Think of SDs, DDs, and CDs as one of the most wasteful processes that we do, because we have these huge batches of drawings where only one set of those drawings is actually valuable. So why don't we just get to it? Why do we have to go through all of these different things? What we should be doing is we should be trying to figure out the most difficult part of that building to assemble, and we should be getting to CDs on that right away, and then that's going to help drive everything else that we do. When we start creating estimates, and this is something I've only recently found out, because I thought estimation was kind of a voodoo process where people cooked it up and wow, it came out, and wow, it's really a good process. Because I mean, there were chartered people, they're people that are, appointed with authority from the crown to do different kinds of estimates. So it must be a profession, it must be really important. But the two things that I found out, that especially in the IPD context, if you aren't responsible for delivering the estimate, your estimate is always going to have hidden contingency in it because of something I call embarrassment bias. Like, we don't want to underprice this thing and be embarrassed that we didn't have enough money in the budget for it. But the other one is that if you really want to go build this, if you're like a politician that needs to go get this thing done, and the price that we're estimating at is too high, you'll just lower that price based on political bias. Or if you're chasing a design bid build contract as a contractor, you'll say, well, nobody's ever going to hire us if we have that much money in there, so let's cut it by 20%. And our superintendent, he's really good, he'll deliver it for that. That's our optimism bias. So the detail of the plans is what funnels us to a better and better estimate. And yet before a building is even designed, we try to come up with an estimate. So I'm working on I'm embedded on the Parliament rebuild up here. And there's lots of pressure to come up with an estimate of how much it's going to cost and how long it's going to take. And it hasn't been designed yet. So that's the kind of pressure that you go, well, how much is it going to cost us? So we could benchmark it. So you look around the world and you go, well, how much did it cost for the last time somebody rebuilt their Parliament building? What did it cost? Well, Australia was the last one, and they just tore it down and built one across the street. And the Scottish Parliament is one of those examples that Ben Flyberg uses on a regular basis as an extraordinarily over budget kind of thing. So it's very difficult to do these estimates with any kind of certainty. So we have to approach it in a different way. We have to do some conceptual estimating. We have to do a lot of benchmarking. We have to do some things where we use our common sense to say, this is about what that should cost based on what we know about the world and what we know about this building. So if we do conceptual estimating in something called parametric cost modeling, so there's a company called Building Catalyst, and they're in Detroit, and they have come up with a parametric cost model. As you could imagine, it costs a lot of money to kind of get all of your data in there. But once your data is in there, you can use a bunch of different scenarios to determine what you think things might want to cost you. So between conceptual estimating and parametric cost modeling, we should be able to benchmark some data that gets us closer and closer to a target of what something should cost. And as we've seen through innumerable IPD projects, we march from heartbreak and strain at the peak of despair where we're, X number of $1 million over budget until we get down below target cost and we actually have some shared savings on the team. And so these are what people who have done IPD projects in the past, where they end up actually getting getting cost savings below the target value, which is, according to LCI, about of the 500 IPD projects that have been done in the States, 485 or something have never exceeded the expected cost, and 450 of them have returned something to the team in terms of shared savings. So, but just think about your own experience and how close estimates are to these things. The other thing is that we don't want people to settle. So if we have an estimate that says, well, it's $180 million, we're done, we can just go forward and deliver it for $180 million. Why would we ever want to settle with that? Because we're constantly looking for new efficiencies to make it better. So how do we actually get that? How do we design to a cost? How do we make sure that we're getting the best value? Well, you have to take all of the options that are available to you, and all of those options have to be considered as you move forward. And then you have to figure out a way of analyzing what those are, converging them, winnowing down those options, and making some decisions about things. And we use a couple of different tricks in that. One is that, so in Ottawa, we developed this optioneering matrix where we consider all the different options for, or we consider all the different criteria. So here you can imagine if you're rebuilding a parliament building, there's lots of historic and heritage and functional systems analysis. There's all kinds of things that you have to go through to make sure that you're doing the right thing. So we did basically a forced +1 or +2 optioneering thing. I'll try to make this a little bit bigger so you can kind of see some of those things. But there's, it's hard to see everything that's in there. But once you get to the last 2 or 3 options, then you do your A3 analysis. It could be a choosing by advantages. It could be a number of different ways of looking at things, but you're picking systems based on that optioneering analysis where you've eliminated things, and then you get down to the overall best system for you. So here's displacement, ventilation, and med surge, which is kind of a really interesting idea if you think about it. And I think about it quite a bit. So I think it's a really interesting idea. Anyway, what we move on to is finally how we manage risk collaboratively. So one of the things that we know about risk is that at the beginning of a project, we know very little about the project and we have lots of unknown risks. So in our traditional model, the time that we know the best about the project is almost near the end of the project. So what if we tried to reverse that? So we took this little sleeping elephant and woke it up, and we said, what if we could know as much as we know about the project as early as possible? So this is what answers the buyer confusion of, well, if we can go find out that information, why wouldn't we go find that out? So that's really what the integrated model is all about, is going out to find the information that you need that actually gives you some sense of what it's going to cost you to be able to do these things. So I wish I had the animation here because this is the greatest animation slide ever. But unfortunately, it doesn't really let me do it. But if you just close your eyes real fast and flick between these two things, you'll see that we can actually move the known, what we know, to the right. And you go, so why is it important for us to know stuff? Well, because there is no risk once you know something, right? All of us fear getting cancer, or right now we fear getting COVID-19. And we take all kinds of different precautions to avoid those risks, whether it's masks or we don't talk to people. I've been in basic lockdown here for 3 months because Ontario hasn't really opened up much. But that's trying to avoid the risk. But if I got it, then I'd have to have a plan of how to deal with it. So the knowledge that I have, it changes my thinking about it completely. So the more we know about what we're doing, the easier it is, and the more predictable it is that we're going to be able to accomplish the goals that we're trying to accomplish. One of the things about this also is how do we reduce, so let's go back to this model for a second and we say, well, not just yet. Let's go over to this. So if we talk about contingent liability, this is something that we had to face with one of the ministries in Canada, because there's a ministry that says if you have contingent liability and you're a Crown corporation and you go out of business, the Crown might have to pick that up. So when I say the Crown, if you're in the States, Queen Elizabeth has more power in Canada than she has, even in England. So we talk about the government as the Crown because she could show up in her crown if she wanted to, and she could take over these projects. So my Canadian friends may have a different opinion of it, but that's why I love it. I think it's kind of cool that it's called the Crown because they signed my contract. So I'm gonna have to call her up and talk to her about that. But if we think about contingent risks, we think about what's the probability of failure on projects. If you have tied up all the money in these models at the very beginning of the project, the risk of that project only begins to go away as you get closer and closer to the finish of it, because you're on the hook for a fixed fee. In the IPD world, you see this little green bar down here at the bottom, you're only on the hook for last month's bills, right? So your contingent liability or your risk is only as much as you owe for last week. Now, if somebody goes out of business, what's that going to take us? Well, it's going to take us a month to get them back up and going, but then we're going to pay them time and materials. So the risk that we're trying to mitigate here is actually much smaller and much more manageable because we have changed the paradigm about how we think our liability should be created. So what's our current risk strategy? So currently we try to sell the risk to another party, and people will always tell you, wow, we should sell it to the party who's best able to manage it. That's our risk mitigation strategy. But what if the smartest people in the room aren't on that team? What if everybody on the project core team has been around construction a lot longer than the guy who just showed up to do the drywall? Why wouldn't we want to jointly manage risk? So why would we ever try to sell that off when we could jointly manage that risk? Like I said, the risk usually goes to the single party that could most usually prevent it. But the jointly risk, if we manage it jointly, where money and losses are jointly shared, we're really focused on getting that moving. Fundamentally, there is a risk in concentrating on activities and not on workflow, and that is that somebody will presume that their activity should go before somebody else's, and it'll mess up the way that we actually do projects. We used to use a slide at LCI that showed piping going up and down and all around ductwork and all over the place because the ductwork guy had claimed the territory first. Just think how much waste there is in that. The fact that we now do modeling helps eliminate a lot of that stuff, but if we're focusing on workflow, how do we improve the ability of people to install the things that need to get installed? Then we're focusing on the right thing. Reporting and oversight. If you've ever worked on a project for the Veterans Affairs Department, they are the most overseen or oversawn or overlooked people in the world. they don't feel really good about a project unless they've gone in front of Congress like 3 times to defend how badly it's been performed. And a few years ago, the government took away the ability from Veterans Affairs to build their own hospitals and gave it to the Army Corps of Engineers, which, you can take your own judgment on whether that's an improvement or not. But driving backwards, just think how hard it would be if you went to work and you drove with in your rear view mirror. Everybody had to drive in reverse. So looking backwards doesn't help us very much. It doesn't get us very far. So oversight is not what we want to do. What we want to do is we want to be active at the site of the work phase and actively managing what's happening. So if you have a schedule issue and you're using the last planner concept, you're moving stickies every single day when things get out of whack, right? So you're proactively managing what needs to be managed. The search for the guilty and the punishment of the innocent, the idea of going around and keeping track of people so you can make claims against them is almost non-existent in this model. Estimating and predicting on assumptions. Let's use all the knowledge around the table to make fewer assumptions. Remember Occam's razor? That usually the right answer is the one that has the fewest assumptions. So I just want to put together a construction company. It's called Ontario Collaborative Construction Arts Management, Occam, so that we use the fewest assumptions ever. The easiest way to get there is the way we're going to go. But we need to have a process for figuring that out. Okay, so finally, what do we know about value and desired quality? So everybody's going to have a different take on this, right? Beauty's in the eye of the beholder. But in the lean world, there's only one beholder, and that's the customer. But the thing you have to remember is that there's a lot of customers. So the beauty that people see, the building that we're building for somebody, if we're building it for Humber College or Harvard University or Brown University, the value is going to be in how they're able to use it. So I shouldn't overbuild something for John Cook at Brown University. I should give him exactly what he wants, exactly when he needs it for the amount of money that he thought he was going to have to pay for it. So what that means is that the value proposition has to run around these circles and will always be influenced by operations, construction, design, development, and the rest of that. But we need to be constantly focusing on the value proposition. So if you think about what the system should look like, if we use Laurie Koskela's definitions of value, ensuring that the customer requirements are met, all relevant requirements are available, ensure that our customer requirements have a bearing on the deliverable, capability of us to produce that stuff, and ensuring that we measured that value proposition, you can get this kind of 6-part circle of how we should be managing projects. So the first part of that circle is client engagement and developing requirements. So that is, this picture over here of this young fellow is the dean of the engineering school at Brown participating in our values workshop. Here are 104 Imagineers thinking about the value proposition for Pandora Land. These are a number of people at a repurposing of an old Navy base in Philadelphia to repurpose some of the buildings there, and how we go forward on that. What we try to develop out of this process is a values matrix. What are the values that we are going to be focused in on? So this is one we recently did at Humber College, and we did values both for the project and for the project team. So how are we going to work as a project team? But every A3 that we do, we have a values matrix on, and we analyze how well the decision we've made sits against the values that we have developed collectively in the group. So at Humber, we had the dean of the School of Music participating in this to help us develop these values so that the team knew what it was that we were designing to or for. Then we distribute those knowledge requirements, and we take that knowledge to optimum design. So we share the requirements, we noodle around what the designs might be, we look at a whole bunch of different types of things, we share information in ways that create an ability to iterate that into the best design. And then we move forward into identifying who needs to do what in order to actually get to the value measurement. So we do these things all along the way. And John, you'll recognize a number of these things from your experience. Here's the dashboard. So we don't need no fancy dashboard. We just need a whiteboard that says every day, every week, how much money are we spending? Where are we? How do we identify for the team what we're up to? This is a very shorthand target value design that we did mid-project about what are the big ideas that we could actually save some money. So whether you do this at the beginning of a project, the end of the project, the middle of the project, you're constantly focused on learning what is important. So how do we get through finally not sacrificing one aspect? Many of you grew up with this idea that you could only pick two of these things. You could never deliver a project that was good on cost, time, and quality. You had to sacrifice one of those. So what if we came up with a new paradigm where we got to pick all three of those? I mean, that's the goal of these integrated processes, is that we never sacrifice one value for another. We compromise some values, but we're constantly thinking about delivering the value proposition. And I would suggest that today, I think that there are 5 values that every one of these projects has to maintain. We're focused on safety. Every project has to be delivered safely. And it's the right thing to do. We're focused on sustainability. I haven't been on a project in the last 5 years that didn't have some sustainability requirement or goal that people were shooting for. So sustainability is one of those, along with cost, time, and quality. So how do we get there? What's the new model and the new paradigm? It really is that we start with transparency and visibility. So what's the process that allows us to be transparent and visible with everything? Because we have to, and this is really very linear. I'm not a guy that normally thinks of things as linear. I think of everything as like 3D chess. But I think of this as, it just keeps writing stuff. It's unbelievable. I think of transparency and visibility first, that you can't collaborate if you have a hidden agenda, right? So one of the reasons that we don't need to have police is because everybody's open about stuff. Nobody is there to game the system. If you are transparent and you're visible, which means that every piece of you, if you look at this picture here, somewhere there's a picture I'm looking for. Come on, show up here. Boom. Okay, so this picture here, this is a performing arts center in Orlando that we worked on. Just think how visible everything on the project is. So if everything is visible and transparent, then you can collaborate. And once you start collaborating with people, you can trust them. So if I work with you and on a regular basis, you say, I'm going to do this, and you continue to do it time and time and time again, then I begin to understand what's up and I begin to trust you. And it's only then that we can ask people to make commitments, because I can't make a commitment unless I can trust that somebody is going to be coming along. That I can't make a commitment to do work unless I know that Bill Proctor's made a commitment to me ahead of time, and he's going to deliver that commitment. This must be Christian in the background messing with my screen because he's on here. Somebody's messing with my screen. Somebody's hacked in here. But commitment is the most important thing, and it's the hardest thing to achieve in construction because you're so reliant on everybody else. And then the thing that commitment leads to is achievement. We actually get stuff done, and by getting stuff done, we produce knowledge. And shame on us if we don't reincorporate that knowledge back into what we're going to do. So why lean? Other than why lean? Because it is a paradigm that actually allows us to answer the questions that we want to answer. The final thing that I will say before I say thank you is that we often think that we can just take some of these tools, these lean tools, and we can edit our procedures. So we think that we could take like a CM contract or a hard bid build design contract, and we just edit it and we turn it into an IPD contract. The whole reason that this is a new paradigm is because it's a new model. It's a system that works unto itself, and you can't necessarily take just one piece and use parts of the old system. You have to commit to the idea that this is the way that we are going to deliver these projects in order to take full advantage of what we call lean, whatever that is.